Another prediction of general relativity is a phenomenon called gravitational lensing. This is called lensing because what a lens does is it bends light and changes its focus. Well, space-time itself could do the same thing because light travels through space-time. So imagine that we're here on Earth and we're observing this distant galaxy. Well, the light from that galaxy travels through space-time in a straight line. But what if between us and that galaxy there is another galaxy, and this has a lot of mass, which means it's going to actually bend the space-time around it, which means the light from the more distant galaxy now is not going to travel in a straight line, it's actually going to travel through curved space and therefore will follow a curved path. Now we might expect that if we're here on Earth, we won't see this galaxy because it's hidden by the other galaxy. But in fact, because of this lensing, this warping of space-time that bends the light itself that's traveling through it, we would actually be able to see this galaxy, only we'd see it off to the side, and we'd actually get multiple images of that same galaxy off to the side. Well, Einstein predicted this from general relativity, and he also predicted mathematically how much the curvature should take place, and lo and behold, we observe exactly what he predicted. Today we observe these strange phenomena. They're called Einstein rings or Einstein crosses, and in each of these cases what we're seeing here is a galaxy that is beyond this galaxy, and the light of that galaxy is being bent around the closer galaxy to create this distorted image. In this case, because of the positioning of the galaxy or galactic clusters, as you'll see in the video, we're actually seeing 4 separate images of the same structure. Another prediction of general relativity is demonstrated to be observable.
How is gravity like nature's magnifying glass? To find out what the universe was like in the beginning, we need to study the most distant galaxies, whose light has been traveling to us for billions of years. But the farther away a galaxy is, the fainter it appears. That makes distant galaxies very hard to see, even for the most powerful telescopes, because they can only collect so much light. Fortunately, nature can provide a helping hand. According to Einstein, the gravity of massive objects can be so intense that it can warp the fabric of space-time. Light, which normally travels in a straight line through space, can show us where this distortion occurs. A very massive object will warp space and bend the path of the light. In a sense, warped space acts like a magnifying glass. A magnifying glass collects and bends light, making a light bulb, for example, appear bigger and brighter. Warped space can do the same thing to light from a galaxy. So what acts like the biggest magnifying glass in space? Galaxy clusters are the most massive things in the universe with the most gravity. When light from a very distant galaxy passes through a cluster, it is amplified and distorted, with the cluster acting like an imperfect magnifying glass. Light that would have gone in other directions gets bent toward our telescope. That lets us see the very distant galaxy in more detail. This effect is called gravitational lensing. Without this natural boost from gravity, it would be impossible for our telescopes to see far away enough in space and time to study galaxies in the early universe.